Thanks for joining us on Newsmakers. I'm Fred Martino. Well, over the past few years, I have had a lot of guests on this show who I would say reach for the stars. But this is the first time that I think I can say that in a literal sense. My guest today is a senior at Calvin College, Andrew Vanden Heuvel. And you may have seen that name before in the paper, seen Andrew on other television programs, because he discovered last fall an asteroid, and this really made the news. You were telling me before we started here that people were talking about this in the Netherlands.
Yeah, it kind of grew bigger than any of us were really expecting. It was covered across the nation and even, in other countries. It was pretty crazy.
You know, Andrew, I was amazed when we talked about doing this show at the equipment and the technology that has come into place at Calvin College to make this kind of thing possible.
Absolutely.
And you were telling me that this particular piece of equipment, which just came in recently, you are able to control a telescope in New Mexico on the internet. Is that right?
Yep, that's absolutely right. We got this National Science Foundation grant for $130,000, which Calvin matched, and that was to buy both a new telescope at Calvin, which we put in our observatory to replace our old telescope, but also to buy a whole new observatory in Heuvel, New Mexico, and we can operate that totally remotely from Calvin over the internet.
And the one in New Mexico was the one you were using to discover this asteroid, is that right?
Actually, we discovered the asteroid at Calvin using the new telescope.
Calvin
Using a new telescope there.
Okay.
And that was even more of a statement of how amazing it was, because Michigan has really poor skies and the weather is always rather poor. So with the new telescope in Rehoboth, we've actually been able to search for more new asteroids and been able to find even more new ones, because the skies are so much better there, and they're darker and the weather's better and more chances to observe. So
those are the main reasons: better weather,
exactly,
and fewer, I imagine, fewer lights and whatnot in the area.
Yeah, it's just darker in general there.
Darker.
Yeah,
and so that's why that was used.
And a higher altitude as well, so there's less atmosphere above you, less chance for the starlight to get kind of messed up in the atmosphere.
Okay, interesting. And this was in the middle of the night that you discovered?
This was. It was, I think it was even before classes started this school year. I stayed up all night I was observing a different asteroid. We were trying to measure the rotation of an asteroid. Asteroids are generally kind of potato-shaped, and when the wider side is facing you, you're seeing more light from it, because there's more light to reflect off the big surface. And then when you get the end of it, there's less light. So what you see is the asteroid's brightness, it gets brighter and dimmer as the asteroid turns.
Okay.
We were trying to measure that for another asteroid named Vanden Heuvel. Actually, it had my last name, although it wasn't named after me. But and while we were observing that asteroid, we found another asteroid, actually several asteroids, one of which was a new one. So this was all, one night at Calvin where we made these images and found an asteroid.
And as I read it, Andrew, the one you discovered that got so much press, there's a temporary name for it, but then since you discovered it, you're going to get to name it, give it the permanent name?
The trick is keeping track of it for enough time. That is, the asteroids, they're all orbiting the sun, right? And you have to keep observing them throughout the year to be able to be sure exactly how it orbits the sun.
Okay.
You have to observe it for a rather long time until you're perfectly sure that you know exactly how it orbits. It takes something like 4 years of tracking the asteroid, keep checking in on it every few months, make sure you know right where it is. So that
you're going to do that, I assume.
Well, in all honesty, the first asteroid, since we discovered it in Michigan, and before we had our New Mexico telescope, we were subject just to Michigan skies. And unfortunately, it was cloudy for about a month and a half right after we discovered it. And we lost that initial asteroid.
Oh my goodness.
So that's bad news.
So you have to discover another one.
Exactly, and we have discovered many more using the New Mexico telescope, actually.
Amazing. Well, let's, we're talking about this in abstract terms. Let's get a look at actually what you saw when you made this first discovery.
Yeah,
we do have an image, and this is on a loop, so we can see some movement, and it's also on a reverse. You actually saw a black background with white. But we did a reverse here to make it hopefully a little easier to see.
Exactly. So there's the circles there which show you what to look at. Those are, I think we have 5 asteroids in this one field, and you can see them moving along as it goes on. And that's what it looks like when you look at the images. This is over some maybe 4 hours that the asteroids have moved this much, and then you can see they look just like stars, but they're moving. That's the fundamental difference.
these little specks moving along, and we see occasionally little red circles to point them out.
Yep.
Does that become real difficult on the eye and a little tedious to look at for hours on end? I mean, you said you were up all night doing
Right.
this.
So we up all night taking all the pictures.
Yeah.
And then at the end of the night, you can play them all as a movie.
Okay.
And then look just once to try
Otherwise
to find
you go
the
nuts,
asteroids.
right?
Yep, absolutely. But it's actually it's kind of fun just looking through this, trying to kind of play like Where's Waldo, trying to find the little dots that are moving. We actually went to a middle school about a month ago, and took images like this and had the students go through to try to find all the asteroids in the field.
Is that
and
right?
Had a good time with it. So.
Did you have a chance to go to the middle school?
Yeah, absolutely.
You did?
Yep, a group of sixth graders at Highlands Middle School in Northview.
That must have been really
Yeah,
neat
it
to
was a
try
great
to
time.
give the kids a little inspiration
Yeah,
of
absolutely.
what they might be able to do in the future.
Exactly, exactly.
We have some other pictures too, Andrew, and
Yeah.
these ones are color pictures,
Yep.
which, I mean, I am blown away that we have equipment in West Michigan
Yeah.
that can take pictures like this.
Right.
This is just, it's
So
amazing.
Exactly.
What are we seeing
A lot
here?
of these pictures were taken in Rehoboth using the new telescope
New
out
Mexico
there where
one.
the skies are better. Yeah.
Okay, what is this?
This is called the Crab Nebula, and it's a supernova remnant, we'd call it. What happened was this used to be just a star, and about 1,000 years ago, that star blew up. It's called a supernova, and actually Chinese astronomers recorded this giant bright thing in the sky that they saw, which was the explosion of that star. And over the course of time, all the material from that exploded star starts to spread out and has all these colors, which are due to the materials that were in the star, and this is what's left now.
Amazing. All right, next frame.
Right, this is called the Flame Nebula, and it's in the constellation Orion, which just sets right after sunset now. In fact, this star in the right there, that's one of the stars in the belt of Orion, and there's a huge complex of these clouds. That's really all these are, just large clouds where stars are being formed out of.
Okay.
And there's just a big complex of those constellations, of those clouds, and this is part of that same complex. This is called the Horsehead Nebula.
Wow.
And you can see it's just kind of a dark region of dust in front of lighter nebulas behind it, lighter clouds that are reflecting the starlight around it. This is something totally different. This is called M81, which is this is a galaxy unto itself, right? This is all outside of our galaxy. So what you're seeing right there is something like 100 billion stars all at once. And you can see the nice spiral arms there and the bright core where there's hundreds of thousands of stars.
100 billion.
Yeah.
How do we know it's that many?
Right,
I mean,
right.
I can't even get my mind around a number
Yeah,
that
in fact,
big.
I mean, you can't even see individual stars there, right? So, like in our galaxy, we can see the stars around us, and we can get a sense of the size of our galaxy. I'm not fully sure, I suppose, how we actually know the exact number of those things, but right, we know it, judging by the area around us, and I mean, we can see most of the stars in our galaxy, and you can kind of extrapolate outward how many stars must be in our galaxy.
Sure.
And assuming that other galaxies have similar numbers.
Well, and I guess today it's a little easier with computer models to
Yeah,
make,
absolutely.
to make some kind of judgment on that.
Sure.
But that's interesting.
This is another galaxy, actually a pair of galaxies that are in the process of colliding with one another. You can see the two galaxies there. This is called M51. It's known as the Whirlpool galaxy. And
Not to be confused with the company, right? So it's nothing to do with it.
Exactly.
Okay, all right.
Yeah, so you can see those guys are kind of in the process of colliding with one another, but that'll take something like several billion years for that
Where
to
did it
actually
get the
go
name, the
forward in time.
Whirlpool, just the way it looks?
Yeah,
I
exactly,
assume,
just
right?
like water spiraling
All right,
around.
all right.
Yep. This is called NGC 891. They have all these crazy names. But this is another galaxy, just like the Whirlpool you saw, it was a galaxy clearly, but this one you're just kind of switching your view 90 degrees. So you're looking edge on to the galaxy.
Yeah.
And you can see that plane of dust and stuff that's in the galaxy blocking a lot of
And
the star's light.
you mentioned the other one that we saw, which was a reddish glow and whatnot.
Right, that's a good
Why is
point.
this one green?
Yeah, so you saw some reddish stuff, you saw a black and white one, you saw a green one. Those are all actually just black and white pictures. And we put them on kind of a false color just so you could see it better.
Okay, okay.
But the initial one, like the Crab Nebula, that was actually in real color. So I'll distinguish which ones are real color, I apologize, and which ones are false color.
Ah, okay.
This is a true color image, I should say. This is called the Orion Nebula. And this is again in Orion. And this is what we'd call a stellar nursery. Stars are forming in this dense cloud right in there. And
So we're actually, when we're looking at this picture, we're seeing stars being created?
in the process of formation, yeah. And as you can look with different colors of light, right? Like you can look in the red light and you can see further inside and you can see the really young stars that are forming in there. It's quite amazing.
Really amazing. I mean, it reminds me of something like from Star Wars.
Yeah,
know?
yeah.
I mean, the way this picture looks has got to be incredibly exciting to be able to work with equipment like this. And when you go into a school, I imagine, really exciting for kids.
Yeah,
'cause
absolutely.
They think this is real, right?
Absolutely.
This is in the movies.
Yeah, absolutely.
Okay.
Yeah.
Very interesting. Lots of great pictures there. You know, getting back to this idea, while I never took up astronomy in any way in college or high school, like no one could tell that from listening to this conversation, right? I was always interested in this because, I mean, I was a huge fan of the first Star Trek series
right.
and watched all the Star Trek movies and the Star Wars movies. How did this become such a fascination for you that you wanted to take this up as a career?
I think astronomy has one of the greatest appeals of any of the sciences. I think, I mean, you hear a lot about Mars and all these things that are, like, people are just generally interested in astronomy. And for me personally, it actually started, I think, in the 8th grade when I first had astronomy in a class. And we learned about the solar system and just kind of learned how big the planets were and how much distance separated them. And it blew me away, just the extreme size of it all. And I started kind of reading books on my own after that and got more and more interested in it and kind of, realized this is where my passion lied. So I decided to pursue it for a career.
And you knew that in high school then?
Yeah, I think I grew to know that as I read more and just kind of started to get a real feel for what the subject was all about and kind of knew that I was good at it and that I really liked it.
Tell me what it did for you as a student to be able to have equipment like this, to see so much of what you're studying about. What did that do for you?
Yeah, so I've had the privilege really at Calvin to kind of, when I came in, we had an old telescope there, a 30-year-old telescope. And I'm now a senior, so I've kind of seen the full switch over from the old school stuff to the top of the line stuff. And it's been fun to do projects with the old stuff and see how it used to be done back, 50 years ago, sort of how hard it was, or how much more difficult it was to do certain projects, and then see what technology really does for us now in terms of being able to have computer-controlled pointing and tracking that's really excellent, and just insanely amazing cameras that can just take excellent pictures. And so it's really given me a sense of appreciation for the technology we have now. I mean, I think a lot of times, like the students who are coming in now as freshmen, maybe they have all this equipment and they're just like, oh great, this is the way it's done. They don't have that kind of reference where they can say, okay, now I can appreciate the quality of the technology that's available now.
When you talk to the average person and they don't know anything like me, they don't know anything about astronomy, right? They see these pictures and that's a beautiful picture, but they don't really know the importance of it. What do you communicate to them about the importance of astronomy and astronomers, and why this constant search for new planets, asteroids, new discoveries, why that's important to society?
Yeah, absolutely. Absolutely, it's a great question. I think part of the reason everyone's so interested in astronomy is it's kind of inherent to our understanding of ourselves. And it's kind of weird, but you think if we kind of understand the universe, how big it really is, and how just the insane number of stars and planets that are out there, and you think of our planet, and you realize how big it is, and how many people there are on it, it's just, it boggles your mind, just even that. And then so it gives you a sense of how small we are in the universe. And in some sense, I think this is the joy of being at Calvin, which is a Christian institution, and to study astronomy. I think a lot of astronomers who aren't religious could easily get depressed about those sorts of things, because you're like, the universe is so huge, and here we are in this little galaxy, one of 100 billion galaxies, and this one little star in that galaxy, on this one little planet, and I'm just one of 6 billion people on that little planet. Who cares about me? But the joy of, I think being a Christian gives you a whole different perspective on that, to say, given this huge universe and how small we are, it makes it so much more dramatic to say that, God cares for me, even though I'm that small little person. So I think there's kind of a unique thing that being a Christian astronomer brings to it, which is the joy of being at Calvin and being able to do astronomy in a Christian environment. And I think that's what's really unique about all this equipment and all that sort of stuff, is that it's at such a small Christian school. Is quite an unusual thing.
Well, that's interesting. And that's a topic that I actually hadn't even thought about when we were going to sit down today. But Is there any interconnection there in terms of the curriculum?
Yeah, well, I mean, having all the faculty be professing Christians helps, right? Where they are free to, bring up in class, how does this impact the way we understand our religion with those things? And I think it just, I don't know. I mean, go ahead and fill in your question a little more, maybe. How does it impact the curriculum?
Well, I'm wondering, I mean, obviously that's something that's touched you personally, that there's some other meaning to this beyond just scientific discovery. But in terms of what you get in the classroom, is there any more to that maybe the average person who won't have the opportunity to be in the classroom might not think about?
Right. I think what's helped me is that in first learning about astronomy and reading these books, they tend to all be written by people who aren't religious. And they would tell you about astronomy in their books, but then they would also kind of have little side comments about how, and this, little side comments about how hopeless it is in some sense, and how all we have is what we humans can accomplish, very kind of humanist type things. So that was distracting. I had to kind of decipher between, okay, what's the science here, and what's the author's, just view on religion or on the world. I kind of had to separate those two things, which was kind of hard. And I think a lot of people see science and scientists as very not religious in any way. And I think it's nice to be able to, my point really is that in the classroom, our job is to do science. When we're in the astronomy class, we're learning astronomy. Because I'm going to be going to graduate school in astronomy, there's certain things I need to know. And that's what the professors are teaching me. So it's Christians teaching me from a Christian perspective, but they're teaching me the science. So I guess it's that play between, I still need to be a professional astronomer, but I don't need to be biased towards other people's worldviews. It can bring those two things together, which I think a lot of people don't see science and religion, particularly maybe astronomy and religion, going together very easily, but it's comforting to have people teaching you who feel that those things go together very naturally.
Sure. Along those lines, the recent films that have dealt with the destruction of the Earth as a result of something hitting us from outer space, right? People have talked about those in religious terms and the idea that that might be Armageddon, right?
Right.
What are your thoughts about that?
Well, I mean, I don't know about that.
Could this happen? Do you think this
could happen? Absolutely. Sure. I mean, it's happened in the past, most likely to the Earth itself, and there's things hitting the Earth every day. It's just a matter of the size of the thing that hits us. But it's been interesting to say, what kind of lead time do we need to have? If we know an asteroid's going to hit us in 300 years, can we deflect it? Can we move it somewhere else, or can we blow it up, or whatever? And it's actually not that difficult if we have that kind of lead time to move an asteroid. I think with the ingenuity of the people on the Earth, we could easily move an asteroid if it were impending doom, if we had, several year lead time.
Is that actually something that you think will become an effort at some point, if there's a belief that something may hit us that could be devastating?
If it was 100% certainty that it's going to hit the Earth, I'm sure it would come up in national circles that we should move this asteroid, I imagine. And it's something, it's actually a calculation we did in one of our courses at Kelvin in the physics department, was to calculate what it would take to move an asteroid if it were going to hit the Earth, and it's very doable. It's not that tough.
Okay.
The question is, if you just haven't missed the Earth, then it's still floating around out there. So it's been suggested that instead of just having it miss the Earth, we should actually have it hit the Moon instead, so that the asteroid's gone altogether, no chance of it coming back to hit us again.
Andrew, the other question that I'm sure you get all the time, and you knew this was coming if I was going to ask you about anything about the larger meaning and the larger questions that we have about the universe. What do you think about life on other planets? And will we one day discover life on other planets?
That's a great question. In fact, one thing I hope to pursue in my graduate work is finding other planets out there, and that's a big part of the push to find other planets, is to find if there's life. One thing I like to say is we don't know of any life on any other planets besides the Earth as of this moment, right? But there are many different levels of life.
Sure.
Right? You could say grass. I mean, grass is clearly life. Right? And would you be really distraught if they found out that there was grass on another planet? That seems almost natural. You'd expect that there'd be grass. Or even little microbes and stuff like that, little bacteria. All that's technically life. And I think it's fairly likely that those things exist somewhere. At least some astronomers think it's exceedingly likely that microbes or bacteria exist on other planets and other places.
What about the more evolved.
Right, right. When you get to higher and higher levels of intelligence, and that it's a crapshoot. And at some level, I don't really care a whole lot, in all honesty. My personal opinion, and when it comes down to it, it's all opinions more or less, is that if there is other intelligent life out there, I really honestly don't think we'll ever encounter it in any way. I mean, I know there are large efforts to contact other, SETI, of course, is using radio telescopes and even optical telescopes to try to get signals from intelligent civilizations, but there's a lot of assumptions built into that, like the fact that if there was an intelligent civilization, it would be trying to contact us, or that the way in which they work is similar to us. Maybe, dogs are pretty intelligent. Maybe that's the intelligent life, but they clearly would be kind of trying to contact us. Or maybe it's a different kind of life altogether that we just don't know about because we don't have it here.
Something we'll leave for the TV and movie producers until there's some definitive discovery, I guess. To get into a little bit more of the technical stuff, although I don't want to go too deep, you did discover an asteroid, and there have been more discovered since then. Give us an idea of what an asteroid actually is and how it compares. How do you distinguish an asteroid from a star?
Yeah, right. Okay, so in a picture of the sky, like a photograph you would take with a telescope, you saw an asteroid looks a lot like a star in the picture, except it moves. That's pretty deceiving because we're just from our little small vantage point here on the Earth, everything's just in the sky, so everything kind of is in the same place and things like that. But fundamentally, a star is extremely different than an asteroid. The best comparison would be like between a planet maybe and an asteroid. An asteroid more or less is just a hunk of rock, a big hunk of rock, but a hunk of rock that's orbiting the sun. And most of them orbit between Mars and Jupiter in what's called the asteroid belt. And these things range in size. They could be extremely small. There's really no small limit. They could be as small rocks. But on the big size, I think the largest one is about 1,000 kilometers in diameter, which, to give you a sense of size, that's about 1/4 of the size of the moon, that's pretty big for a thing that's just kind of out there. We normally think of asteroids being a little smaller, maybe. A majority of them, though, are in the, there's a range between 1,000 kilometers, and the ones that we can see are at about 1 kilometer, like these faintest ones.
And beyond these things, a big one of these things hitting the Earth, what are some of the other reasons why we look for them and study them?
Yeah, so they're kind of like leftovers from the creation of the solar system. So you can think of the solar system as forming out of a big disk of debris that was originally orbiting the sun.
Is that the Big Bang we talk about?
This is much after the Big Bang. The Big Bang would be the whole universe forming. And this is much later. This is maybe only 4 billion years ago instead of 15 billion years ago. But this is when our solar system maybe first formed. So you've got the sun in the center, and you've got kind of a disk of just stuff going around it. And the planets kind of accumulate out of that disk, kind of agglomerate together. And maybe some of that material doesn't get to a planet, and it's kind of left as just a few little pebbles and rocks on that kind of scale, which turn out to be these large asteroids out there. So it's kind of,
amazing stuff. Andrew, you're a senior at Calvin. You're going to be going on to graduate work in astronomy. What do you want to do?
So with your bachelor's degree in astronomy or in physics, there's not a whole lot you can do right away necessarily in the field of science. So you generally go on to get your PhD. And with that, you can be a professional astronomer where you would do research, say at a government lab like NASA, or even at a university where you just do research full time. Or you could teach at a university while you're doing research, or at a smaller college. Or you could go on into a totally different field, business or economics or something like that, where scientists tend to get a lot of experience in computer work and things like that while getting their advanced degrees, so they have a lot of desirable qualities that could be hired from other professions as well.
All right. What route do you think you're going to take?
I would like to I'd like to teach, I think, at some level, whether it's at a university or a smaller college or something like that. I enjoy kind of sharing this with people who are eager to learn those sorts of things.
That's great. So you've had a chance to do that even while you've been at Calvin.
Absolutely.
That's super. And getting out into the elementary schools is really neat. I bet when you describe some of this stuff and get a chance to see some of the pictures that you showed us today on the show, the kids just sit there in awe.
They're having a great time. It's awesome. What's great too is that this kind of stuff can be done by someone right after high school. If they're leaving high school and go right into college, and they jump right in and start doing this kind of
Do
stuff.
it.
It's really exciting.
All right. Well, it's been exciting having you on the show
Yeah, it's
today,
been a
Andrew,
pleasure.
and good luck with your
Thanks.
academic career and then where you move on from there.
Super.
Keep reaching for the stars.
Yeah.
All right. Thank you so much for joining us today on Newsmakers. We'll look for you on the radio, too. Join us every weekday from 5 in the morning until 7 at night. We're West Michigan's only NPR station with local news, weather, and traffic. Talk to us, too. The address, feedback@gvsu.edu, or drop me a line in the mail, 301 West Fulton, Grand Rapids, 49504. And we'll see you next time on Newsmakers.